Okay, so welcome. So we are going to do these new type of problems today called latitude problems. So you're probably like, I know about latitude and longitude, but how does this relate to trig? So I will show you that in a moment. So with these problems, we are going to be using the arc length formula. How exciting. Now, we've seen the arc length formula, but it's always good to remind us what the heck it is. So the arc length formula is S equals R theta. Okay, I like that formula. It's pretty quick. There's nothing too crazy about it. Just a reminder, theta has to be in radians. So we just need to keep that into account in the back of our minds here when we are plugging into it. Okay, so that's exciting. So the next thing, I'm just going to just write it down. You're going to be like, I don't even know what you're talking about. But it's one of those things we just kind of need it as we do the problems. But you'll be able to visualize it in a minute. So it says how to find the angle between, sorry, I have like a million papers here, between the cities. So I'll show you in a second, like what the heck I mean between the cities and all that stuff. But just write this now because we're going to need this. If they're in the same direction. So what I mean when I say that, if you kind of look at this first problem, see how you have two latitudes. See how one's north, one's south. Those are opposite directions. So we'll talk about what we do then. But sometimes they'll be in the same direction, both north, both south. So both north or both south. You are going to subtract your angles. Woo. If they're in opposite directions, like this one with the north-south, so if opposite directions, but this is something I do recommend writing down because it's something we kind of refer back to a lot. So one north, one south. We're going to add the angles. And once again, we'll be able to actually visualize what that means in a second, but for now, we'll just write it and kind of refer back to it in a moment. So I'll leave that up for a second just because I know it takes a minute to write things down. Check one thing quick. These kids. Okay, so now let's see, like, what the heck do we do with this? What does that even mean? For the first few, I'm just going to draw a picture. You don't need to do this for everyone. It's more just to kind of visualize what we're talking about, and then we'll actually do the problems out. So I'll show you how to do them. So I was going through all my old trig stuff, and I've been teaching this for a while, like 12 years. And I had like a lot of worksheets and I was like, oh, like I'll just do this worksheet, like whatever, that'll be easy. But the worksheet had like 5 different types of problems. So I am trying to kind of streamline it. So today we're just going to do one type of problem. So we'll just do it. We'll do a few examples. I'm going to cut back on the types of problems we have. So I think I did 5 before. We're going to do 2. So we're going to do these latitude problems and we're going to do problems that relate to a clock. So we'll do those next week. So we're kind of trying to focus on one thing at a time. I know it's hard at home, so thank you for bearing with me. One, motivation is like very low, I'm sure. And 2, just like learning math on a computer is just not natural. So we'll try to do one thing at a time. So I kind of reorganized everything just to have this one type of problem. So today, if you don't get it, just ask. Because if not, we will move on kind of in the future. But hopefully focusing on one thing at a time is semi-helpful too. So here's what the example will look like. We want to find the distance in kilometers between 2 cities, okay? They're on latitudes 28 degrees north and 12 degrees south, okay? So we'll visualize that in a second, what the heck that means. The radius of the Earth is 6,400 kilometers. Okay, so here's what we're actually talking about. We are on Earth. Earth is a circle, right? Okay, beautiful. Through Earth, we have something called the equator. The equator is the exact middle point, right? Well, that's a terrible line, but you get the idea. So we'll pretend that's the equator. So what happens is on Earth, like on the circumference, there's countries and cities and all things. So if you go somewhere, you're in a different spot. So what we're saying is there's one city on the latitude of 28 degrees north. When I say 28 degrees north, that just means from the equator, go up 28 degrees. And then there would be a city right there. Okay, that kind of makes sense. And then the other one is 12 degrees south. So all of our measurements are done from the equator. So south is down. So 12 degrees south, we'll say is right here. And then that's our city. Okay, so that kind of makes sense. We're on Earth. The thing about Earth is it's round, so it's curved. So that's why we have to use the arc length formula. You can't just do like a regular triangle because that has a curve to it. And that's what arc length is. So that's kind of the visual of what's happening. Now we need to figure out what's the angle between these cities, because I want the angle between here and here. I don't want two separate angles. So that's where this comes in. So that's why we kind of wrote that first. So if I say find the angle between the cities, you say I have a north and a south, which are opposite directions. So I'm going to add these two things. So I always kind of just organize myself first. Look at your directions. If they're opposite, you're going to add them. So right here, I'm going to add 28 degrees plus 12 degrees. And that's going to give me an angle of 40 degrees. Okay, so that wasn't bad. Not a bad step. It's just having that information there. And once again, you can always refer back to it. So have it written down. So the issue is we have an angle in degrees, and that doesn't really help us. We want the angle in radians because anytime we plug into that formula, we need radians. So we're going to convert it to radians. So I just tried to kind of do steps as we were going. So I'm going to convert this to a radian. I'm going to take 40 degrees, and I'm going to multiply it by pi over 180. That gives me 40 pi over 180, right? Because remember, the main thing is we want to cancel the degree symbols. This is the one that I plugged into that calculator before. So if you have a calculator, great. Use that online one. If you have one that you're like not, I don't know, super tech savvy on. So I'm just going to do it on this one just to show you this type of calculator again. So this is a CalcPal, like AKA, I don't even know where they got these, but a lot of you have the TI ones that look like this. So just as a reminder in your calculator, helps if I actually turn it on. When I plug this in, I'm just plugging in 40 over 180 and reducing that. Okay, I'm not putting pi in at this point. So in here, I'm going to do 40. I'm going to find my fraction button. Some people's actually looks like a fraction. This one, it's a little like ABC button. So I'm going to hit that, and that just is representing a fraction. I don't know why they couldn't just make a fraction bar, but whatever. And then 180. So when I hit enter, it will reduce it for me. So that's the reduced fraction of 2 over 9. And then when I write my answer, I just put that pi back in. So just as a heads up, if you need calculator help, let me know. Okay. So we have what we need now because we have our angle, I'm on the wrong computer, in radians. We have the radius because it was given to us, so that's all we need. So I'm going to plug into my formula S equals R theta. So when I plug in R, basically for every single problem here, it's going to be the same. So the Earth's size doesn't change. The radius of the Earth is 6,400 kilometers, so 6,400. And then our theta is our radian from up here. So that's 2 pi over 9. Okay. So I'm going to, once again, grab my calculator. I'll grab the same one. I want to plug this in. This time I'm plugging my pi symbol in. Boop. I just want to see the whole calculator here. So when I say plug in my pi symbol in, I'm going to do 6,400. I'm a parentheses user, so I do that times, or you can just put it next to a set of parentheses. So when I say 2, I'm going to put the pi in. So you have to find your pi symbol. Mine is above right here. It's kind of hidden there. So I have to hit shift and then this button. And you can see it goes in as the pi symbol. And then over 9, I just do divided by 9. Sometimes with the fraction button, it gets messed up. So just divided by 9 and hit enter. And that's going to be my answer. So I'll put my answer over here. It comes out to 4468.04. And I'm going to label it with kilometers because it is a distance. We want to make sure we know how we're measuring it. And that would be your final answer. So if we think about like our little quiz that we took yesterday, we converted, we plugged into formulas, we found answers. So really the only new step is finding that original angle. So just knowing whether to add or subtract. So I'll leave that up for a second. See if you have any questions. Feel free to either shoot me a message in the chat or you can always interrupt. Ooh. I just know it's hard to kind of get caught up when you're looking at a computer and you're trying to write stuff down. I feel you. Oh, thank goodness it's Friday, guys. I'm hoping my poor little baby boy got tested for COVID yesterday. We're hoping it's negative. Let's see if that. Whoever said that kids don't get COVID is a liar, by the way, because we've been quarantined twice, or my kids have been quarantined in 2 weeks. Liars. Hopefully it comes back negative. Poor baby. Okay, so we're going to do another example. So for these examples, I kind of like did the steps out in detail. For the ones on the back, I don't write every step out. You can kind of, refer back to it if you need it. But it was more just to kind of break everything down for you so you have all the steps if you need them. So example 2. Same looking problem. We're just, these are changed, but everything else is the same. So it's just kind of plugging in those different angles. 2 cities are in a latitude of 72 degrees south and 34 degrees south. So I'm going to draw a little picture. Once again, you don't need to do this every time. It's just for us to kind of visualize as the first few problems. So we got Earth. We got the equator. Okay. The first city is at 72 degrees south. So from here, I'll say I don't know. These aren't nice in any way, shape, or form, but we'll say that's 72 degrees. Once again, south you go down, north you go up. The other one's 34 degrees south, so that's also south. So from here, we'll go down there. We'll say that's 34 degrees. So if I have one city here and one city here, I'm trying to find that distance. It kind of makes sense. If they're in the same direction, they're going to be closer together. So you would subtract them to get a smaller angle. And if things are in opposite directions, they'd be further away. So that's why you would add. So it kind of makes sense when you can visualize it. Once again, we just want to find this angle in here. And we do that by subtracting. So once again, when I see south and south, when I see the same direction, I just remind myself I'm going to subtract. So to find this angle, I'm going to do 72 degrees minus 34 degrees. And that's going to give me the angle of 38 degrees. So I just do a quick plug in, nothing too crazy. So now we're going to convert this. So we're going to take this 38 degrees and we're going to convert it to radians. So we always multiply by that same fraction, pi over 180. So I rewrite it as 38 pi over 180. And then just remember, I'm just reducing that. Okay, so I'll just grab my calculator. 38, I hit my fraction button, 180, and it will reduce it for me. Or you can use that online calculator, or if you have a different calculator, go for it, but just know how to use something. And that's going to give me 19 over 90. So I'm going to rewrite that as 19 over 90. And then don't forget that pi symbol we put back in. Okay, so we kind of have everything we need. We just need to plug into our formula. So basically these first few steps are just getting that angle into the form that we need it. S equals r theta. Let's plug those bad boys in. Radius is always the same, and I'll always tell it to you. You don't need to remember that, but the radius of the Earth is 6,400 kilometers. And then the angle in radians, just make sure you're plugging in the radians, is 19 pi over 90. Beautiful. So I grab my calc again. Keep bringing this baby back. So we do 6,400 times, or you can just put it next to a set parentheses, 19. I find my pi button and plug it in over 90 because we want these in just a decimal form. If you put things in terms of pi, it's kind of hard to I don't know what the heck's happening. And that gives me my final answer of, oh, I can't even see it, 44.64 kilometers. Okay, so I'll leave that one up for a second. Just trying to balance it there. Ooh. So once again, drawing the picture, that was more just for the first few to visualize what's happening. But you should be able to find the angle between the cities, whether you're adding or subtracting, whether they're the same direction or opposite. You should be able to convert that to radians, and then you should be able to plug into that arc length formula. Give you a few more seconds just if you're catching up. Okay, so I'm going to flip. Once again, I have a worksheet just for life. You know, I'll try. I have another worksheet on Monday. Sorry, it's just like it keeps me more organized. So cohort A, I should see you. I'll have it printed for you. Cohort B, I'm just going to post it today. So if like, like maybe a parent can print it at work, or someone over the weekend that you can grab a copy from. I mean, I just like worksheets. I find like I just stay way more organized with them. So I'll post it today. So then if you have time to print it for Monday, it might help you out. So I'll try to post things early if you need it, or if I think printing would be of use to you. So. Okay, so on the back, here's what we're going to do. I'm going to have you guys try 1 through 4, so I'll just re-explain what you're doing. We'll do one more together. We'll do number 5 together just as a reminder / review. And then you guys are going to try 6 and 7 as kind of the wrap up that you will be scanning into Google Classroom. So just as a heads up, you do need to scan your work. I'm still waiting on people to scan their work from block 1. They're about to get marked as a cut. So please get that work in. And if you have any questions, let me know. So what is the angle between the two cities at the given latitudes? So I'll just say this has to be in degrees. I don't care, but you don't need to convert it or anything. So just as a reminder, oh my gosh, I have the itchiest nose. This is what I usually do. I look at the angles and I look at their directions. First thing I notice is those are opposite. Once I see opposite, I put a plus, and then you can just remind yourself to add. So once again, that's why we wrote this down at the beginning to refer back to. Opposite directions, you add. Same directions, you subtract. So right now, can you look at your other ones here and say, okay, are they the same or opposite? And should I add or subtract? And then actually add or subtract them. So can you, I'll give you like a minute or two, find the 4 angles for those, just to make sure that new step you're good with. And then we'll try one more problem just to see that you're okay. So I'll give you a minute for that. For those ones, you can use a phone calculator, right? You're just adding or subtracting. For some of the other ones, that scientific might be a little bit more useful to you. A few more seconds, we'll go over them. Those ones should be pretty quick, 1 through 4. Oh, I guess I'll be already today. Okay, so let's look at those. They should hopefully not be too bad. So I just organized myself first. Opposite directions, add, and I just add them. So I just threw it in a calculator because I was too lazy to do it in my head. Number one should have been 45 degrees. Okay. So number two, north, north, same direction, subtract. So that's kind of what I do to organize me. So now that I see that I subtract, I literally just subtract 55 minus 12 and I get 43 degrees. Just as a heads up, if I had said like 12 first and then 55, don't do 12 minus 55 and get a negative. You never want a negative angle. You can always just rearrange and do your larger minus your smaller. So your angle should always be positive. So you can always move things around if you need to, but just make sure you are getting a positive angle. South, north, opposite you add, and that should have given you 44 degrees. South, south, same direction you subtract, and that's 49 degrees. I don't know why they all came out in the 40s, but I was in some sort of 40 mood the other day. So that's those. Does anyone have a question on those first few? Oh, I don't see it in the chat. I'm so sorry. Oh, my goodness gracious. What a day. All right, so we're just going to do one more, and then you guys are going to try 6 and 7. So just as a reminder, like this one, you can see I didn't list all the steps out. It just says using the steps from the first page. So if you needed to go back and look at those, go for it. I don't need to see like a sketch. It was just like a quick little drawing just to show you. But if you need the detailed steps, they should be written out. Find the distance between the cities using the arc length formula. Okay, so the first thing I need to do is find the angle. And I'm basically going to do what I did in 1 through 4. I'm going to look here. I'm going to say a north and a south, opposite directions. I'm going to add these. Okay. So theta is 51 degrees plus 12 degrees, which comes out to 63 degrees. Okay, so that wasn't bad. Pretty quick step. But as I'm kind of just going through my steps before, I didn't have to do the drawing. I did find the angle between the two. The next step was to convert this to radians. So we're going to multiply this by pi over 180. So I'm just kind of going right in the line. You don't need to do all new stuff. So I grab my calculator because I have 63 pi over 180, but I want to reduce that. So in here, I'm not putting the pi in for this part. I'm just doing 63 fraction button 180. And that comes out to 7 over 20. And then I'll just put that pi back in. Okay. So my angle in radians is 7 pi over 20. Beautiful. So that's now going to be my theta. And I'm going to plug in. S equals R theta. S equals R is 6,400. Basically for all of these, it will always be that. And theta, we're using our radian of 7 pi over 20. I grab my calculator because I'm plugging in. This time I am going to plug the pi in because I just want a decimal answer, because putting something in terms of pi, it's kind of confusing if I asked a distance. So when I throw it in, it's 64, I like parentheses, 6,400 times 7 pi over 20. I press enter. 7037.17, and that's kilometers. That would be your final answer. So just like kind of bringing a lot of things in that we've been doing, but kind of put them in one problem. So the converting, the plugging in, and now you just have to find that original angle. So that's that. Okay. So your goal over the next few minutes is you guys are going to try 6 and 7. So let me kind of bring them down here. You don't need a, where's my piece of paper I was using? You don't need a C8. So there's other ones at the bottom. We'll probably just do those as kind of like a warm up on Monday, just to remind ourselves what we learned and hopefully not forget it over the weekend. So you are going to be attempting 6 and 7 over the next few minutes. When you are done, you are going to scan your work from today. So obviously I need to see 6 and 7 because I'm actually going to go through and check that people are understanding. But I want to see like your notes as well. So when you're scanning, you're kind of scanning what you got. You're going to submit it into today's assignment. It just says like latitude problems. So you submit it there. And then you'll get credit for doing the work and you will get your attendance from there. So that's how you get marked present. You participate. So that's that. So you're starting to work on 6 and 7 now. If you have any questions, let me know. I'm trying to think if there was anything else I needed to tell you guys. I can't think of anything. Oh my God, I guess I got it. So I can't think of anything else. I'll randomly think of stuff in a second. So sorry. So bear with me. But you're working on that now. Yes, so thank you, Emily. When you are done and it's submitted, you may log off. Do not log off this meet until you've submitted it. But once you can just log off. You don't need to tell me. So have a lovely day and a lovely weekend. It's the weekend. Once again, I am going to be kind of checking because I want to see if people know what they're doing on 6 and 7. So please make sure I can read it. But once you've submitted, then you may sign off the meet. I'm sorry in advance. This is gonna come down for 1 second. It's just I'm recording and now I'm just like awkwardly recording myself. So it will just take me 1 second to turn it off.